All right, in this video we are going to talk about radian measure of an angle. So before we start into that, first thing I just need to remind you about the circumference of a circle. Remember, that's the distance around the edge of the circle. Okay, so if the circumference of a circle, or the circumference of a circle with a radius r, would be 2 pi r. So 2 pi times the radius. Okay, so, and remember what pi is, right? Pi is an irrational number. That means it has a non-terminating, non-repeating decimal expansion, right? It starts off 3.14159, and the decimals don't repeat in any pattern, and they never terminate, right? So whenever you're dealing with a number like that, there's always the question about, well, how many decimal places do you want me to take it out to? And a lot of times with the rational numbers, to avoid that question in algebra, we just use a symbol, for it, like square root 2 or e, and pi, right? It's just one of those numbers. Okay, so the thing is where that number pi comes from, right? If I have a circle, it doesn't matter if it's a huge circle or a little circle. If I take and divide the circumference by 2 times the radius, it always comes out to be the same number. Whether it's a little tiny circle, right, with a small circumference and small radius, or whether it's a really big circle with a huge circumference and radius. Okay, so it's sort of a intrinsic property that circles have, and so that's kind of what's special about that number pi. All right, so we're just going to have to recall those facts when we talk about radians. All right, so that leads us into radian measure, and so we want to measure an angle in radians. What we'll do to do that is put a circle with a positive radius over the angle, with the center of the circle at the vertex. Okay, so here's an angle that we have, and so what we'll do is just put a circle, right, with the center right at the vertex, right? So the center of this circle is at the end point, or the vertex of the angle here. Okay, so that's the first thing that we would do. All right, and next what we would do is measure the distance around the circle between the initial and terminal sides. All right, so assuming that here we just rotated, that this angle is in standard position, right? We just rotated from here to here. What we would do is measure that green distance right here, the measure along the circle, right, between the initial and terminal sides. Now, if we rotated the other way, right, we would measure this part, or if we rotated around, like say 3 or 4 times before stopping here on this terminal side, we would have to measure that whole distance. Okay, so we're just measuring the distance around the edge of the circle from the initial side to the terminal side. So we would measure that out and write that down, and we're going to call that value S. Okay, and then what we would do is divide S by the radius of the circle, right, and get S divided by R. So the radian measure of that angle is S over R. All right, so we would basically lay a circle over the angle. We'd measure this distance right here, and then we'd measure this distance right here and divide those two to get a number. All right, so here, let's start off with, right now this angle in degrees would be, from here to here, would be 40 degrees. Okay, and then don't worry too much about the this symbol right here. This is just a formula to figure out what S is. Okay, so S, if I measured this green segment here, it would be 2.792, whatever that is, right? That would be what S is, and then the radius of this circle is 4. So I would take this number, 2.79, and divide by 4, right? And that comes out to be 0.698, right? So on. So that would be the radian measure of this angle, 40 degrees. All right, so when I first saw this, my first thought was way why are you making this so complicated? What's wrong with 40? That seems a lot simpler than this stuff that you're talking about here. And degrees have been around forever. Everybody knows them. So why are you measuring the angle this way? And unfortunately, that's a little hard to say right now. Say why. In my opinion, it makes things much simpler later on. This is pre-calculus, right? So in calculus class, angles are measured in radians, and there's a good reason for doing that. It does simplify things somewhat and make things a little bit easier to deal with. And that's just, one reason why this might be better. But I definitely remember recalling that, or I definitely remember thinking that this is complicated. Why don't we just go with degrees? It wasn't until later on, when I took calculus and started realizing, okay, it does make sense why you would measure angles this way. Okay. All right. So there is one catch to this, and you might have noticed it if you were thinking about, okay, I put a circle over here. I really didn't give you any directions at all about how to do that. So you might say, well, what if I use a little tiny circle like this, right? I'm going to measure this angle's, I'm going to measure this angle in radians, so I just use a little tiny circle. What if I use a little tiny circle? Would I get a different result than if I used a really big circle? If so, that wouldn't really help, okay? That wouldn't be a really good way to measure angles, right? If the measure could change when you used a little circle or small circle. Now you can see here, if you take a look at it, when I change the rate, this slider that I'm using in Desmos changes the radius of the circle, right? So I'm getting a bigger radius and a bigger S value. This length of this arc right here is getting bigger as well. So you can see that the value for R changes and the value for S changes. But if you look down here and pay attention to this is the radian measure, S divided by R, right? As I change this slider, you can see that this number is not changing. Yeah, R is changing, yeah, S is changing, but S divided by R is changing. So that means it doesn't matter what size circle I use. I'm going to get the same number, whether it's a big one or a small one. All right? So a lot of times what we'll do because of that is just use a circle with radius 1. That makes it pretty easy because then the radian measure and the length of this little green line, the green arc here, are the same, right? But you can use any size circle, doesn't matter. Okay. So let's take a look at some specific conversions. But before we do that, we'll make this notational convention. All right, so angles, measurements given in degrees, you must use the degree sign, okay? So you put a little degree sign up here, so this would be 30 degrees. So angle measurements with no degree sign are in radians. So if you put 30, right, that is 30 radians, which is definitely not the same as 30 degrees, okay? So again, you got to be careful about that. If it's in degrees, you put the degree sign. If a problem says, hey, the measure of this angle is 30, and they don't give a if they don't give a degree sign, right, then it's in radians. Okay. A lot of times it will say 30 radians, just to be clear about that, but it's something that you do have to be careful about here. And whenever going through this class from here on out, that is something that you will have to be extremely careful about. Are we talking about degrees or talking about radians? All right. One huge difference it makes is in your calculator, right? In your scientific calculator, when you're evaluating, there's a degree mode and a radian mode. So you're always going to have to be careful in this class, like which mode that you're in, all right? And it depends on whether you're using degrees or radians. All right, so let's look at some examples. The first example, it says find the radian measure of a 90-degree angle. Express your answer as a rational multiple of pi. So when I say that, that's a fraction times pi, and also as a decimal. Okay. So what we're going to do is, let me pull this up so I can write on it. So what I'm going to think about is a 90-degree angle, or supposed to be 90 degrees, like this. And I'm going to measure it in radians. So I'm going to put a circle around it. Okay. And what I'm going to do is make the circle be radius 1, right? I can use any radius I want to. We just talked about that previously, right? And so I'm going to use radius 1, right? And then looking at my formula for the circumference of a circle, C equals 2 pi r. In this example, right, the radius is 1. So I get C equals 2 pi. So what that means is the distance all the way around the circle, right, from here all the way around to here, is 2 pi radians. Okay. So if you're looking at a 90-degree angle, right, it's 90 degrees right here, and we're rotating from here to here, that means that that is exactly 1/4, right, of the circle. So this distance of here is exactly 1/4 of this. So 2 pi times 1/4, right? If I make this into a fraction and then multiply the top and the bottom, I get 2/4, 2 pi over 4, which is equal to, and 2/4, right, is the same as 1/2. Pi. So you'll see it 1 pi over 2. You'll also see this written as pi over 2. Another way you'll see this also written is 1/2 pi as well. So you can write that as any way that you want to, any of these ways here, but usually not this one with the 1 times pi. You usually see it written like this, pi over 2 or 1/2 pi. These two are exactly the same. If you're confused about why that's so, right, why pi over 2 and 1/2 pi are why they're equal to each other, you can just write it like this. If I write this as 1/2 times pi over 1, right? I wrote this as the multiplication of two fractions, right? And remember, how do you multiply fractions? You multiply the tops, right? Pi times 1 is pi, and you multiply the bottoms. 1 times 2 is 2, right? So pi times 1 is pi, 1 times 2 is 2, so these are equal. And then, right, anything over 1, right, if I take any real number and divide it by 1, it just comes out to be itself. So what that means is that 1/2, or pi over 1, is the same as pi. All right, so it's 1/2 times pi. And then in algebra, right, we generally don't write this multiplication symbol here. We can just write it as juxtaposition here, and so that's what we do. This is 1/2 times pi. So you can write either of those however you want to. Okay, so what that means is that 90 degrees is the same as pi over 2 radians. All right, so this answer is the conversion in a rational multiple of pi, a fraction times pi, which can also be written like this. Okay, it says also write it as a decimal. So to do that, we are going to go to calculator. So I'm just going to go to Desmos and punch that in. Pi over 2. All right, and you can see that pi over 2 comes out to be 1.57 radians, okay, to 2 decimal places. Let's see where we're here. Okay. All right, so 90 degrees, an angle of 90 degrees would be the same, right? Its radian measure in radians would be pi over 2 or 1.57, depending on whether you want it as a rational multiple of pi, in other words, a fraction times pi, or if you want it as a decimal, 1.57. Which way do we want it depends on what you're doing. A lot of times we'll just leave it like this. Other times we will change this, right, to this to make some other calculation. Okay. All right, next up, let's do the radian measure of 180 degrees. All right, so 180 degrees would be a straight angle, right? So the angle with the initial sides over here, terminal sides over here, right? And we put the circle there of radius 1, right? We want that distance right here from here to here. Okay, well, that's half of the circle, right? If I measure this distance around the circle, right, that from the initial side to the terminal side, that's half of the distance all the way around. We know that the distance all the way around is 2 pi, right? So for 180 degrees, we're going to take the distance all the way around and cut it in half. So we would divide by 2, so we get pi radians. These two cancel each other out. All right, and then as a decimal, that would be 3.14, right? If you plug that into your calculator, or just happen to remember what pi is as a decimal to 2 places. Okay. All right, so that's how to convert back and forth, right? Just by the process, putting the circle over there and going through. But you can see that that process would be a little bit difficult for some other, like what's 37 degrees, converting that. 37 degrees, what fraction of the circle is it? So this way is okay to do the first couple of examples to get you down. But what we really want to do, moving from here on out, is when we convert back and forth, is to use the fact that 180 degrees is the same as pi radians. So that pretty much gets used as the conversion factor when you're converting back from degrees and radians and vice versa. Okay. All right. So let's see where that leaves us here. Yes. All right. So here is the conversion, right, between degrees and radians. The usual conversion that you use is 180 degrees equals pi radians. Okay. And so I'm going to cut this video off here. And then in the next video, we're going to work through making these conversions.